When track lighting transformers are turned on, they draw a high surge of current, known as inrush current. If the breakers aren't rated to handle this inrush, they may trip. Loose connections can also cause arcing, increasing current draw and tripping breakers. 20 amp breakers are often used for lighting circuits exceeding 12 amps. If the measured current is only 2.9 amps, oversized breakers might be the issue. Transformers can also develop internal faults, causing excessive current draw and breaker trips. To solve these problems, firstly, install breakers rated for inrush current, such as Type CL or Type Hacker breakers. Secondly, ensure all connections are properly tightened at the transformers, contactors, and switch. If the load on each track lighting circuit remains below 3 amps, consider using 15 amp breakers instead. If the problem continues, test the transformers for faults using a multimeter and replace any defective ones. Also consider other factors like line voltage fluctuations, circuit overloading, or issues with the switch or control circuit. Use high-quality wiring and components throughout the system. Ensure adequate ventilation around the transformers to prevent overheating. Monitor the current draw on the circuits over time to identify any anomalies. Let's delve into each of these potential causes and solutions in more detail. Inrush current is a common culprit when dealing with inductive loads like transformers. Standard circuit breakers react quickly to overcurrent situations, but inrush current is a very brief surge. Breakers designed to handle inrush current have a time delay characteristic, allowing them to tolerate the surge without tripping. Type CL breakers are specifically designed for lighting circuits, while Type Hacker breakers are suitable for heating, air conditioning, and refrigeration equipment, but can also handle inrush current in lighting circuits. When tightening connections, pay close attention to the wire nuts, screws, and terminals. Loose connections create resistance, which generates heat and can lead to arcing. Arcing not only increases current draw but also poses a fire hazard. Ensure that the wires are properly stripped and inserted fully into the connectors before tightening. If you suspect that oversized breakers are the problem, calculate the actual load on each circuit. The total wattage of the lights divided by the voltage will give you the current draw. For example, if a circuit has 10-12 volts 20 watt bulbs, the total wattage is 200 watts. Since the transformer steps down the voltage from the line voltage to 12 volts, you need to consider the primary side current. Assuming a line voltage of 120 volts, the current draw would be 200 watts divided by 120 volts, which equals approximately 1.67 amps. If the calculated load is significantly below the breaker rating, using a smaller breaker can prevent nuisance tripping. Testing transformers for faults requires a multimeter capable of measuring resistance and voltage. Firstly, disconnect the transformer from the power source. Secondly, check the primary and secondary windings for continuity. Thirdly, a reading of infinite resistance indicates an open winding, while a very low resistance reading suggests a shorted winding. Also, check for continuity between the windings and the transformer case, which should not exist. If you find any of these conditions, the transformer is faulty and should be replaced. Line voltage fluctuations can also cause breakers to trip. Low voltage can cause inductive loads to draw more current, while high voltage can stress the insulation and lead to faults. If you suspect voltage fluctuations, monitor the line voltage with the multimeter over a period of time. If the voltage is consistently outside the acceptable range, contact the power company to investigate. Overloading a circuit can also cause breakers to trip. Ensure that the total load on each circuit does not exceed 80% of the breaker rating. For a 20 amp breaker, the maximum continuous load should be 16 amps. If you are unsure about the load on a circuit, use an amp meter to measure the current draw. Issues with the switch or control circuit can also cause breakers to trip. A faulty switch can create a short circuit, while a malfunctioning control circuit can send erratic signals to the contactors. Inspect the switch and control circuit for any signs of damage or loose connections. Use high-quality wiring and components to ensure reliable performance and minimize the risk of faults. Use copper conductors of the appropriate gauge for the load and insulation rated for the operating temperature. Also, use high-quality connectors and terminals that are properly rated for the application. Proper ventilation around the transformers is essential to prevent overheating. Overheating can degrade the insulation and lead to faults. Ensure that the transformers are not enclosed in a tight space and that there is adequate airflow around them. Monitor the current draw on the circuits over time to identify any anomalies. Use an ammeter to measure the current draw under different operating conditions. Keep a record of the measurements and look for any sudden increases or decreases in current, which could indicate a developing problem. When working with electrical systems, always follow safe work practices. Firstly, turn off the power to the circuit before working on it. Secondly, use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. Thirdly, if you are not comfortable working with electricity, consult with a qualified electrician. The National Electrical Code, or NIC, provides comprehensive guidelines for safe electrical installations. Familiarize yourself with the relevant sections of the NEC and follow its requirements. For example, NEC Section 210.21 B1 states that a branch circuit shall not supply a load that will cause the overcurrent protection device to be loaded to exceed 80% of its rating. NEC Table 310.15 B16 provides ampacity ratings for conductors based on their size and insulation type. NEC Section 450.3 covers the overcurrent protection requirements for transformers. Understanding and adhering to these codes can help ensure a safe and reliable electrical system. If the issue cannot be resolved, consult with a qualified electrician. A qualified electrician has the training, experience, and tools necessary to diagnose and repair electrical problems safely and effectively. They can also ensure that the electrical system complies with all applicable codes and regulations. In summary, troubleshooting track lighting breaker trips requires a systematic approach. Firstly, identify the possible causes. Secondly, test and eliminate each potential issue. Thirdly, implement the appropriate solutions. By following these steps and prioritizing safety, you can resolve the problem and ensure reliable operation of your track lighting system. The initial step in diagnosing the problem is to visually inspect all the components. Look for any signs of damage, such as frayed wires, cracked insulation, or burnt connectors. Also, check for loose connections at the breaker panel, switches, contactors, and transformers. Use a non-contact voltage tester to verify that the power is off before touching any wires. Once you have visually inspected the system, you can begin testing the individual components. Start by testing the circuit breakers. Use a multimeter to measure the voltage at the breaker terminals. If the voltage is 0, the breaker is tripped. Reset the breaker and measure the voltage again. If the breaker trips immediately, there is a short circuit somewhere in the system. If the breaker holds, proceed to the next step. Next, test the switches. Use a multimeter to check for continuity across the switch terminals. When the switch is on, there should be continuity. When the switch is off, there should be no continuity. If the switch does not pass this test, it is faulty and should be replaced. Then test the contactors. A contactor is an electrically controlled switch used to switch a power circuit, similar to a relay except with higher amperage ratings. Use a multimeter to check the continuity across the contactor terminals. When the control circuit is energized, the contactor should close and there should be continuity across the power terminals. When the control circuit is de-energized, the contactor should open and there should be no continuity across the power terminals. If the contactor does not pass this test, it is faulty and should be replaced. Lastly, test the transformers. Firstly, disconnect the transformer from the power source. Secondly, use a multimeter to check the resistance of the primary and secondary windings. Thirdly, a normal transformer should have a low resistance reading on both windings. A reading of infinite resistance indicates an open winding, while a very low resistance reading suggests a shorted winding. Also, check for continuity between the windings and the transformer case. There should be no continuity. If the transformer does not pass these tests, it is faulty and should be replaced. The symptoms suggest that the issue is inrush current. Consider replacing the existing breakers with circuit breakers designed to handle inrush current. These breakers have a delay tripping characteristic that allows them to tolerate the brief surge of current that occurs when the transformers are turned on. Another possibility is that the transformers are drawing more current than they are rated for. Check the nameplate on the transformers to determine their rated input current. Use an amp meter to measure the actual current draw of the transformers under normal operating conditions. If the transformers are drawing more current than they are rated for, they are overloaded and should be replaced with larger transformers. Also, consider the ambient temperature in the area where the transformers are located. High ambient temperatures can reduce the current carrying capacity of electrical components. Ensure that the transformers are properly ventilated and that the ambient temperature is within the manufacturer's specifications. If the transformers are located in a hot environment, consider using transformers with a higher temperature rating. Finally, check the wiring for any signs of damage or deterioration. Look for frayed wires, cracked insulation, or loose connections. Replace any damaged or deteriorated wiring with new wiring of the appropriate gauge. It's also advisable to consult with a qualified electrician to perform a thorough inspection of the entire electrical system. They can identify any potential problems and recommend the appropriate solutions. They can also ensure that the electrical system complies with all applicable codes and regulations. Remember to prioritize safety when working with electrical systems. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, consult with a qualified electrician.